Hi, I'm XU-NYU Xu. This is my NYU Math PhD application video.
What are your goals in getting a PhD degree in mathematics?
Well, for my PhD, I would like to explore more areas in applied math and find my research interests. I also would like to learn more about math and learn more about research. And finally, I would like to create something new. After completing my PhD, I would like to go to a university or the research department of a company like Google to continue my research.
What's your favorite theorem or subject in mathematics?
Well, last summer I did a summer research in UCLA, and after that I became particularly interested in machine learning. There are many interesting stuff in machine learning, such as hidden Markov model, Bayesian methods, and matrix factorization, and each of them have various applications in real life. But my favorite theorem is in analysis, Weierstrass approximation theorem. And I like it because it has both theoretical and practical value. Well, the theorem says for any continuous function on a finite interval can be approximated uniformly by a sequence of polynomials. My favorite proof of this theorem is using Bernstein polynomials. It also gives us a way to construct the approximating polynomials. It loses no generosity to consider the continuous function on the finite interval from 0 to 1. Then we can define the Bernstein polynomial of order n by this. Bernstein polynomials have many good properties, and using these properties, we can prove that as n approaches infinity, the Bernstein polynomial will approach the continuous functions f uniformly. Now let's look at this theorem again. If we define the distance of any continuous functions by their maximum absolute difference, then we got a metric space. What the theorem tells us is that the polynomials are dense in this metric space. And if we combine the losing theorem, we can prove that polynomials are dense in LP. LP is a large function space, and it's complicated. And many functions in real life can be found in LP. However, polynomials are simple, and it can be evaluated by the computer. So using this theorem, we can use the computer to handle them, to approximate the functions in real life. And also, this is the reason why in regression, we can use polynomials to fit the dataset.
Why do you choose current, and why do you think you are a good match for the program?
During my research at UCLA, there was a talk given by Professor Sontag from Current. The talk was very nice and aroused my interest in machine learning, so I think Current must be a great place for research. My mentor also told me that the professors there are very willing to help young students, and it's a great place for research. About myself, I think I have a solid mathematical background and the potential to be a good researcher, as you can see from my CV. More importantly, I have interest in applied math, and I have the passion to use my knowledge of applied math to make better lives for people.